Good afternoon, everybody. I'm not able to see you guys, see your comments today. So I'm using a different version of Google Hangouts, because I plan to share my desktop today. So hopefully you can all hear me, and I'm going to dive right into it. As you know, I plan to keep these Tech Tuesdays quite short. The goal is to keep them short and digestible so that you can get a feel for what we're doing behind the scenes and what our plans are in terms of technology, and what the premise and what the essentially what you've purchased tokens for, and you can understand that quickly. So this week we're going to continue from what we talked about last week. We're going to talk about how that integrates and works with Sparkster's decentralized cloud. And then we'll end with how do you make money from Sparkster's decentralized cloud? What's the specific mechanisms behind the scenes in which enables you as a token holder and a device contributor to make money from Sparkster? So let's jump right in. What we're looking at is the white paper. And specifically, we're going to start with what's the premise here, in terms of why do I think that Sparkster's decentralized cloud in the long run will be successful relative to traditional cloud computing. And it really comes down to this graph. So what you're looking at here is the red line is traditional cloud computing. And what it says is that as you add servers, VMs, nodes, whatever you want to call them, the value of cloud computing has always been that the cost remains uniform. You pay the same amount of money for every server, right? And so your costs per server or maybe per user stay constant. However, with decentralized cloud computing, especially in the way that Sparkster's designed decentralized cloud computing, one of our greatest benefits is that as we add nodes to the network, not only does the TPS increase, but the cost of running software on a decentralized cloud decreases, right? And that's really the key. Not only does the TPS increase, but the cost decreases as more people join the network. And towards the end of this discussion, we're going to get into why that's the case, right? So this is really the premise behind Sparkster's decentralized cloud. So in last week's discussion, we talked about we talked about a washing machine, and we talked really about three pieces. We said that there's the microcontroller that controls the actual physical machine, and it controls the components of that machine, whether it's the drum, or whether it's turning on and off the water, or pump or turning on the dryer for drying your clothes or whatnot, right? But we said that there's a function that enables you to create a routine, right? So we said that, in a delicate wash, you might turn the water on for 10 seconds and then turn the water off. And then you might spin one way for 10 minutes and then spin another way for 10 minutes. And you might call that procedure a function. And that function would live here on these, what we're calling compute nodes. And they're the ones that execute functions or execute procedures. Now, that procedure and the device would generate data. So the device might generate data that tells you when it began, right, the delicate wash. What it's doing right now, it's doing a delicate wash. And if it knows how long a delicate wash takes, maybe 20 minutes, then it can tell you that, in 20 minutes time, current time plus 20 minutes will be the time when the machine will be available. That data would exist here on, essentially the blockchain component where the data is stored, right? So one of the things that we achieved this week, if you read our tech write-up that was released yesterday, One of the major achievements that we had this week is that we were able to get these compute nodes to execute a function in 5/10,000ths of a second. If you take a second, divide it into 10,000 pieces, right? In 5 of those 10,000ths of a second, we're able to execute a function on a compute node. In the past, we've really talked about the blockchain and how the blockchain, where the data is stored, is able to achieve 10 million transactions a second, right? And we've actually demonstrated live here on YouTube us actually achieving 52,000 transactions a second. So what we've really achieved and what was momentous about this is that we've got high performance throughout the entire network, whether it's the compute component, which today in blockchain environments is the real limitation, right? Bitcoin, their TPS limit is 3 transactions a second. Ethereum's TPS limit is about 7, or in that neighborhood, 7 to 13, depending on how you look at it. We're able to show that we can achieve thousands and thousands of transactions a second here, but we're also able to achieve extremely high performance with the compute nodes, right? So moving on, because I want to keep this short, how do you make money from all of this? If you guys are interested and you want me to cover in more detail how Sparkster achieves 10 million transactions a second, and we really cover that here in this part of the white paper, let me know and I'll dedicate one of these tech talks just to this, right? But as a snippet, what we're really doing is we're streaming transactions to multiple cells or multiple blockchains in parallel. And that's how we're able to achieve really high TPS. But let's move on. We'll talk about how do you make money from running software. I'm sorry, running a node, right? And that means running a compute node or running a storage node on our network, right? So really what's happening here is that if you look at this, this is saying that the probability of you being assigned a transaction is a function of the number of tokens you stake, right? And what that really means is that we don't have a set threshold. So for example, you don't have to have 5,000 Spark tokens to spin up a node. You can have any number of tokens, right? And that any number of tokens, it can be as little as 1 token. That 1 token means that at some point in time, you're likely to get a transaction to execute because it's a probability function. Now, your probability with a small number of tokens is less, and with a higher number of tokens is more, but it doesn't mean that the person with the highest number of tokens gets all the transactions, right? And if we move on, the mathematics gets more sophisticated because we're looking at things like response time and availability, especially if you're a storage node, right? So it's not just number of tokens, but we're also looking at, how available is your node? What's your uptime like? A node that comes and goes a lot is going to get less, is going to have a lower likelihood of being assigned a transaction than one that's there all the time, right? And is always available. And response time is the same, right? If you've got lower response times, then you're less likely to get a transaction. But what this response time allows us to do is to kind of assign transactions to nodes that are closest to you as well, right? And because they're close to you, they'll have a lower response time responding to your request, and therefore your data is closer to you and the whole system works faster. Now, before we move on to this, one thing I do want to say, and this stuff here is actually quite important. What I do want to say is that it's not just, although it's a probability function, and you're likely to be assigned a transaction no matter how much you contribute, one of the things that we talk about here is that if there's essentially an exchange within Sparkster's environment that's matching what the customer customer is willing to pay and what the provider of the node is willing to accept in exchange for the use of their device. So let's say that a company like Panasonic wants to run software on Sparkster's network, and they're willing to pay 1 Spark token per function execution, right? Well, if you've got nodes and those nodes are, some people want to charge 5 Spark tokens a function execution, others want to charge half a Spark token per function execution. Well, the nodes whose price is above the threshold will get excluded, right, from the determination, from this probability determination. And that's really, what's kind of going on here later in the mathematics. But what this means is that because you're able to decide what price to sell your node for, or what price to charge per function execution or per piece of information stored, what this means is that, as more nodes join the network, more people compete with one another to reduce the price that they're charging, right? And that's fundamentally how we deliver on this premise. Now, if you remember, in the beginning, I talked about the more nodes that join the network, the price per operation, or the price per execution, or the price per node falls, right? And that's because the probability distribution is not just a function of how many tokens you stake, but also a function of, of matching how much the company like Panasonic is willing to pay, and then who is providing their devices at a price that's less or equal to what that company's willing to pay, right? And so this is how we end up with being able to drive down costs. And why is that important, you might ask? If we're driving down costs and we're fundamentally disrupting the price of traditional cloud computing, right, then you're going to see a huge amount of adoption with our decentralized cloud. Because ultimately, it's the cheapest way to run software, and it's reliable. It's not centralized, and therefore it's reliable. So I'm going to let you guys think about that and digest that in today's talk, from today's talk, and we'll continue exploring this idea of, how Sparkster will be delivering this service and understanding some of the concepts that we're building into our network over the course of this series of discussions. Like I said, I do want to keep it short, so we'll leave it there, and I'll see you back in the Telegram channel. Thank you, everyone, for your time. I'll see you next time. Bye-bye.